plasma proteins synthesized by the liver. The liver is the largest gland in the body, consists from hepatic lobes. Histologically, the hepatic lobes consists from hepatic lobules. The building unit of the hepatic lobules is hexagonal cells or the hepatocytes. There are variety of plasma proteins synthesized by the liver, including albumin, alpha and beta globulins, coagulation factors, including the fibrinogen or factor 1, prothrombin or factor 2, factor 5, factor 7, factor 9, factor 10, and factor 11. Plasma proteins of the complement system: plasmin, alpha-1 antitrypsin, and alpha-2 macroglobulin. Albumin is the major plasma proteins in the blood, synthesized mainly by the liver. Albumin has two important functions. Number 1, prevent the loss of fluid in the interstitial tissue. Number 2, albumin is the major transport protein. The first function of albumin is to prevent the loss of fluids in the interstitial tissue. There are two forces that maintain the circulating blood constant, which are the hydrostatic pressure and the osmotic pressure or the oncotic pressure. At the arterial end of the capillary, the hydrostatic pressure is higher than the oncotic pressure, which push the fluids outside the capillaries. At the venous end of the capillary, the oncotic pressure is higher than the hydrostatic pressure, which result in pulling the fluid back into the capillaries. Hypoalbuminemia or decrease the albumin level in blood will result in failure of withdrawal of fluids from the interstitial tissue, which result in accumulation of fluid in the interstitial tissue and may result in edema, ascites, and pulmonary edema. The second function of albumin is that albumin is the major transport protein for bilirubin, metals, ions, enzymes, amino acids, hormones, free fatty acids, drugs, and phospholipids. Fibrinogen is a glycoprotein synthesized in the liver, and it is one of the coagulation factors that play an important role in the formation of clot, as fibrinogen is converted to fibrin threads by thrombin at the site of blood vessel injury, which result in the formation of the blood clot. Also, fibrinogen is an acute phase protein, and its level is elevated in cases of inflammation. Plasma fibrinogen level is elevated in cases of inflammation because it is one of the acute phase proteins. Also, fibrinogen level will decrease in cases of chronic liver diseases, leads to bleeding tendency, and characterized by increased coagulation time and bleeding time. Prothrombin is an essential blood coagulation factor that synthesized in the liver, where vitamin K is converted into prothrombin in the hepatocytes. The vitamin K is essential for synthesis of prothrombin in the liver. So dietary sources of vitamin K is ingested and reach to the intestine and then absorbed from the intestine to the liver. Deficiency of vitamin K in the diet will result in decreased level of vitamin K reached to the liver and will affect the synthesis of prothrombin in the liver. In the small intestine, vitamin K need bile pigment to be absorbed. This because bile pigment function of the bile pigment is to help the absorption of the fat, and vitamin K is one of the fat soluble vitamins. So in the presence of bile pigment, vitamin K is absorbed and reached to the liver. This means that absence of bile pigment will affect also the absorption of vitamin K and will result in hypoprothrombemia. As we mentioned before, the liver consists from hepatic loops, and the hepatic loops histologically consists from hepatic lobules, and the building unit of the hepatic lobules is hexagonal cells, which is the hepatocytes. Vitamin K is stored in the liver cells, and it is the site in which the vitamin K also is being converted into prothrombin. First, this is the dietary form of vitamin K, or vitamin K quinone, which is converted in the liver into vitamin K quinone by the action of the vitamin K reductase. After that, the vitamin K quinone is converted into vitamin K epoxide by the action of the enzyme vitamin K gamma glutamyl carboxylase, and then vitamin K epoxide is converted into vitamin K in quinone by the action of the vitamin K epoxide reductase. During the conversion of vitamin K quinone into vitamin K epoxide, prothrombin precursor is being converted into native prothrombin. So the presence of vitamin K quinone is very essential for the synthesis of native prothrombin from the prothrombin precursor. In this step, any factor that interfere with the conversion of the dietary form of vitamin K into vitamin K quinone will affect or interfere with the conversion of vitamin K quinone into vitamin K epoxide, will affect the synthesis of native prothrombin and will result in hypoprothrombemia. This means that liver disease characterized by hepatic necrosis or liver cirrhosis will result in hypoprothrombemia and increased bleeding tendency. Another factor that affects the synthesis of prothrombin in the hepatocyte, which is the warfarin, which is anticoagulant, inhibits the vitamin K epoxide reductase, and so affect the conversion of vitamin K epoxide into vitamin K quinone, and also affect the process of conversion of vitamin K quinone into vitamin K quinone. This will decrease the level of vitamin K in the liver cells and also affect the process of conversion of prothrombin precursor into native prothrombin. Hypoprothrombemia will result in prolonged prothrombin time, prolonged bleeding and coagulation times. Alpha-1 antitrypsin. The liver is the site of synthesis of alpha-1 antitrypsin. It is generally known as serum trypsin inhibitor. It protects tissue from enzyme inflammatory cells, especially neutrophil elastase. Neutrophil elastase is being released in response to bacterial infection and environmental pollution, and also tobacco smoke. In the presence of the neutrophil elastase, the alpha-1 antitrypsin is being active and inhibit the toxic effect of the neutrophil elastase on the elastin that present in the wall of the alveoli. In absence of alpha-1 antitrypsin, neutrophil elastase is free to break down elastin, which contribute to the elasticity of the lung, resulting in respiratory complications such as emphysema, chronic obstructive pulmonary disease, and also liver cirrhosis. Alpha-2 macroglobulin. The liver also is the site of synthesis of alpha-2 macroglobulin and inhibitor of a variety of other proteases. It functions as an inhibitor of fibrinolysis by inhibiting plasmin, an inhibitor of coagulation by inhibiting thrombin. Alpha-2 macroglobulin may act as a carrier protein because it also binds to numerous growth factors and cytokines such as platelet-derived growth factor, basic fibroblast growth factor, and insulin. Plasma proteins of the complement system. The complement system consists of a number of small proteins found in the blood, in general synthesized by the liver. The complement system is a collection of blood and cell surface proteins to help the abilities of antibodies to clear pathogens from an organism. The complement system has four major functions, including lysis of infectious organisms, activation of inflammation, opsonization, and immune clearance.